Hello, I'm Stephen Batiuk of the University of Toronto, bringing you another episode in our series Uncorked by Archaeology Now. In this episode, we're looking at spirits. Not the spooky kind, but the tasty ones. Now, creating spirits involves moving from a more naturally occurring beverages with a low percentage of alcohol to one that has significantly more human intervention and resulting in a significantly higher alcohol content, the result of that meddling. With spirits, there's more technology involved, and in theory, that's why spirits are the latest form of alcohol to emerge. Now, I say in theory because there's enough evidence that's emerging over the last few years that the necessary technology was invented earlier than we ever could have generally understood. And very likely one day there will be a discovery that will change our understandings about the development of spirits. But presently, they do not emerge until about the medieval period, well, the 8th century AD. And their development is tied to two unlikely but ancient industries, that of perfumes and alchemy. Now, to understand it all, you have to understand the basics of how spirits are formed. That's through the process of distillation. Specifically, the distillation of one source with a low level of alcohol to a pure and more concentrated form. Distillation, in essence, is a method of separation based on the phenomenon of the liquid-vapor balance. Basically, you're playing with the different boiling points of substances in a mixture. In the case of alcohol, you take something like leftover grape must from wine production. After you've pressed out all the wine you can from it, it'll still contain a significant amount of wine residue in it. And then you boil it off. Alcohol, specifically ethyl alcohol, the stuff we drink, and water have two different boiling points. 78.4 degrees Celsius or 173 Fahrenheit for alcohol versus 100 degrees Celsius or 212 Fahrenheit for water. Both will be present in the must. And because of this, alcohol will evaporate before the water. In pot distilling, the vapors from the heated mash will travel into a cooling tube, where it will then condense into a pure form of alcohol. So long as you don't heat it too much and boil the water and then condense the water, it will collect purer alcohol. So if you keep it at that 78.4 degrees Celsius. But alcohol isn't the only thing that comes with it. Volatiles, called cogeners, so things like esters, tannins, methanol, fusel alcohols, also evaporate during the distillation process, and they give the spirits their distinct flavors. Now, methyl alcohol is there as well, and it's quite dangerous, but it's found naturally in all fruits and can also be created during the fermentation process in higher percentages. Now, pure methanol is poisonous to people and can cause blindness and even kill you. As little as 10 milliliters of pure methanol can blind someone, and as little as 30 milliliters, so the amount of a standard 1 ounce shot glass, can kill you. Methyl alcohol has an even lower boiling point than ethyl at 64.4 degrees or 148 degrees Fahrenheit. So it will boil and condense first. So our early bootleggers probably would have learned quickly that the first stuff that comes off the still would have a bad smell and would have tasted horrible, and maybe even discovering the dangers of it. And they probably would have learned to discard it pretty fast. There are probably a lot of problems and accidents at first with the development of distillation, but once it was mastered, it really took off. And of course, what we're interested in here is when this actually was. And this is when things get a little interesting. Now, as we've seen, the distillation of alcohol is simple yet complex. You know the basic chemistry and physics behind it now, but what about the technology? And in reality, the technology is not that complex. You need a vessel in which to heat the original alcohol or source. Then you need a way to capture the fumes or the gases of the alcohol as they rise up from the vessel as it heats. Then a way to cool the said fumes, and a vessel to catch the distillate. Now, the Greek philosopher Aristotle described the basic principles of distillation in the 4th century BC, albeit he was describing it in regards to the distillation of seawater into fresh water. Now, classical stills consist of a retort, a vessel where the primary liquid is heated, and then it will have a receptacle. Very traditional retorts are made of glass, with this sort of bent and narrowing neck that's used to capture and compress the fumes, making them begin to condense. The further that neck stretches away from the heat source, the cooler the gases will get, and the distilled liquid will then be directed into the receiving receptacle. Eventually, metal will become the preferred medium for distillation, in particular copper, because it transfers heat more efficiently than an insulator such as glass. In fact, the understanding in distillation goes back some 6,200 years ago to the Chalcolithic period in the Near East. Excavations at the site of Tepe Gawra in northeastern Iraq have revealed what we now understand to be a ceramic still, but in this case not used for alcohol, but for essential oils or perfume making. A number of distillation systems were found at multiple levels at the site, suggesting that it was relatively widespread and it was a long-lived industry at the site. The stills themselves were quite simple, consisting of two simple bell-shaped pots that would fit one into the other, with the top one having two holes in it. Some sort of perforated vessel or perforated boundary was set up inside the first one to hold the material whose scent was being extracted. In the case of Gawra, probably juniper or pine needles. The lower vessel would be filled up with water. The pine was put in the perforated vessel and closed with the lid on top. A reed would be attached to the hole in the side of the vessel to release the steam and allow the distillate to be directed into another vessel. The system would be put into a fire, the water would boil, the steam would break down the organic material, carrying away the fragrant oils, which would then travel down the tube and condense to be collected and rebottled. This basic technology was developed over 6,000 years ago and was all that was necessary for creating spirits, only was never really applied in this way. The use of distillation for perfumes continued to be used in the ancient world, from the Mohenjo-daro of the Indus River Valley civilization in Pakistan, dated to the 3rd millennium BC, a similar still was found. At the site of Pyrgos in Cyprus in the 2nd millennium, and well on into the Iron Age, where at the site of Nineveh, one of the Neo-Assyrian capitals, a number of tablets were found describing the distillation process for perfume making, dated to the 7th century BC. So by the time of Aristotle, the whole concept and the technology of distillation had been well known for almost 4,000 years, just never applied to alcohol. Now, you might actually see some references to alcohol stills that were excavated at the site of Ashkelon in Israel, which is dated to about the 9th century BC. But the installation there is totally different, consisting of a jar buried in the ground, surrounded by stones and shells. It doesn't even remotely resemble any of the stills that we have seen in the past. And more importantly, there's no evidence of a heat source that you would need for the whole distillation process. Even the excavator himself does not really share this interpretation of it being a still. So we have no evidence of alcohol being produced in the 9th century. As far as we can tell, the distillation of alcohol does not emerge for another 1,000 years, not until the 8th century with the development of alchemy in the Islamic world. Now, alchemy was a branch of the natural philosophies, emerging out of the classical Greek period. The Hellenistic city of Alexandria in Egypt was the center of alchemy for the Hellenistic and Roman periods. Although it was more concerned with metallurgy and converting base metals into gold, it was also looking for ways to develop the Philosopher's Stone and the elixir, or the waters of life, of Harry Potter fame. By the 6th century AD, many of the natural philosophers and groups like the Nestorians left the Greek world for more tolerant places like Iran, because they would not convert to Christianity. As well, early Christian anti-Semitism also drove many of the Jewish scientific groups to find safe harbors in the Muslim world. Muslim scientists read and translated many of the works these groups brought with them, and pushed the frontiers of science incredibly far, much farther than was anything happening in Europe at the time. And they made great strides in science, medicine, and industry, including glass making and perfumes. It seems the distillation of wine was something that had been developed by the Muslim world by about the 8th century BC. Now, wine may have been prohibited in Islam, but that certainly did not mean that it wasn't made, drunk, or more importantly, experimented with. You can almost see how these different industries might have emerged or collided in this respect. Maybe someone who had a knowledge of perfume making was either making wine or visiting a winery, and smelling the fragrant grapes thought maybe he could turn that smell into a fragrance. There's plenty of must left over from winemaking, so maybe it was one of those chocolate and the peanut butter moments, the bringing of two good things together to create something new and magical. Now, Jabir ibn Hayyan, an 8th century Muslim scientist and alchemist, is credited with the invention of alcohol distillation, or at least first describing it in texts. Ibn Hayyan wrote mostly on the science of balance, which focused significantly on reducing all of their elements down to their base materials, of which distillation obviously would have played a central role. He's also credited with developing the Alembic, the classical distillation vessel, consisting of two retorts joined together by a glass tube. Or even the term Alembic comes from the Arab term Alembic, which means that which refines or transmutes. We even get the word alcohol from Ibn Hayyan, who called his distillate alcohol, meaning the base of the mixture. Once discovered, alcohol would have wide uses in the scientific world at the time. A solvent for medicines. It would have revolutionized the perfume industry, and of course would have been a staple of drinks in the Middle Eastern world. Even today, arak, which literally means sweat, taken from the idea of alcohol condensing or sweating as it comes off the still. These scientific ideals spread far and wide across the medieval Arab world and found a strong home with the Arabs of Al-Andalus in southwestern Spain, who are actually credited in specializing in the arts of the distillation of spirits. And it's not until the 14th and 15th century when Europe is finally introduced to distilled alcohols. And this happens in two ways. The first way is obvious through Al-Andalus and the Reconquista, with the integration of southern Spain back into Christian Europe. Through that, Europeans were introduced into Islamic and lost Greek science, as well as the art of distilling alcohol. But also on the eastern flank of Europe, the Turkish invasions also brought with them distillation and other unknown sciences. Medieval Europeans found ways to develop the technology further, first through the introduction of the cooling tube, later through the use of copper for better heat exchange. Combining it with their long history of fermented alcoholic drinks from a bevy of different fruits and starches, you see a plethora of regional spirits emerge. Schnapps, rakia, palinka, and slivovica. And then, of course, with the old alchemist footprints being preserved in the French name eau de vie, or the Scandinavian aquavit, the waters of life. Thanks so much for watching. Be sure to check out our other episodes of Uncorked and more original video content from Archaeology Now. Be sure to subscribe and ring that bell so you don't miss out. See you next time.